Hi and welcome to another Motec webinar. My name's Pete Swinney and today's subject is setting up NOC control on a live engine. If you're watching this webinar, you should have already watched setting up NOC control, the software version. Watch that and goes through the basic parameters in a PowerPoint presentation. Now we're just going to go through it live on an engine here in the Motec dyno room with using an LS1 multi-throttle body engine as our test bed. We'll just switch to the M1 Tune software now. Okay, you can see we're online here. It's connected and it's green, and we're sitting in the tuning workbooks and we're on the fuel worksheet. Now there's a couple of places you can get it, the NOC settings in the GP package, which is the package we're using here today as our demo. Alright, so in the tuning worksheets there is the sixth worksheet is the NOC tuning, and this is basically what you're looking at while you're tuning the engine itself. It's not most of the setup, it's some of the levels here that you would look at, and it gives you access to the settings to bias the cylinder voltages for individual cylinders. Alright, so you can change these settings, but we won't be able to change those until we get started. Alright, so if we're going to be doing this and working around these worksheets, it's kind of nice to allocate a quick key to this NOC worksheet. So I thought I might show you that so you can get an idea of how that works. Right now I've already allocated F5 to the fuel and ignition worksheet, and of course this follows on from the M800 and M4 days. So if I just press F5 here, you'll see I'm on fuel, and F5 again I'm on ignition. I've also allocated F8 to the fuel mixture aim worksheet, which of course follows on from the M800. Now what I want to do is allocate a spare key, and I'm going to go with F7. I'm going to allocate that to our NOC worksheet, our NOC tuning worksheet. So just to show you how that's done, if we go to Layout, Layout Editor, Key Bindings, we've got 4 keys we can allocate to certain worksheets, and when you press the key they'll go there. Now you can see F5 currently is allocated to 2. So as soon as you allocate it to 2 worksheets, it just means if you toggle it, it goes from one to the other. So we could have had the tuning workbook and the fuel worksheet as our first one, and we could have actually toggled that with the NOC. We could actually put the NOC worksheet, which is worksheet number 6, and we could put that tuning/NOC worksheet and toggle between the fuel and the NOC. But in this case I'm going to allocate F7 to the NOC worksheet. So we've got it ticked here to customize the F7 hotkey, and we're going to add. So this is looking to find out which worksheet we'd like it to allocate this key to. So we just come down here and we see we're in this is the old GP package name, single port plenum injected engines, which is now GP package or GPR. And we're looking for the NOC worksheet. So we just go OK. And now you'll see F7 is allocated to the tuning workbook and the NOC worksheet. If we look on F8, we can see we're on the tuning workbook and the mixture aim worksheet. Alright, so we just go close. Alright, now, so because you're, for example, using F5, I'll press it instead of clicking it with the mouse, F5 to the F5 key to switch between those worksheets. No longer can you use F5 to look at the properties of, say, the time graph. Alright, so if I go to press F5 to look at the properties on the time graph, of course it just switches to the fuel sheet. So if we just go back in and see what it does, key bindings, what it does is it allocates any, if you take away any of these hotkeys from their normal task, then to do that normal task, it then adds the Alt key to it. So Alt F5 will do what F5 used to, which is of course go to the properties of any worksheet, or sorry, the properties of any component that you've got highlighted. Alright, so now if I press F7, we're straight to the NOC worksheet. Okay, now let's go to the NOC setup itself. So down to Initial Setup 2, and we've just gone, I was here earlier so it remembers where you were, and we're into the NOC setup. Now this is in the setup worksheet, so what that means is we don't expect to be coming here that often, not during normal tuning anyway. So first thing we've got is NOC mode. So this is whether it's enabled or not. It's quite simple. You can choose whether to turn it off. Then we've got 4 frequencies. So what you need to do is choose 4 frequencies that you'd like the ECU to look at for us to determine which frequency shows up the NOC trace the best. We're looking for a frequency that shows the most noise for NOC, or sorry, the most signal for NOC and the least signal for noise. It's called noise to signal ratio. So there's not always a guaranteed known frequency for any given engine. Most of the time, if you've got no idea, you should start around the numbers I've given you there. And in fact, the default is pretty much 10 to 12. It will get probably 60% of the engines out there today. You really should have a look at this for every time you put a new engine on the dyno or you're tuning it. You can go through this process. So what the system's actually going to do is, because it's got onboard frequency analysis inputs, it can individually search through these dedicated or parametered frequencies and display to us what the noise of the NOC signal looks like, or the NOC sensor. So we're going to log all of these, and I've already set up that in the logging now. And we're going to see which one of these frequencies we think shows up NOC the best, and we'll run the engine shortly and show you that. Right, just going through the other parameters here. NOC active delay. Alright, so what this means is the amount of time after an ignition cut event that we don't look at the NOC sensor, because often you get stray NOC events happening while you're cutting ignition due to rev limiting, things like that. So we don't necessarily want NOC control to be active at that time, and there may want to be a small delay of say 20, 30, 40 milliseconds afterwards. Right, just while we're here, we'll show you how to quickly configure a table. So if I put the highlight over here, in fact if I click back to the parameter here, the way to bring the focus over is simply to push enter, and you'll see it go over there. Now we just push A for axis the way we always used to, and you can see we've only got one axis available here. We can click it, we can generate the table, we can start that at 0. This engine goes to, let's say, 7,000, and we'll go in 500 increments. Alright, it's telling us that we require 15 sites and there's only 11 available. So we might start this off at 2,000, and now we've got 11 sites required and 11 available. So bang, that configures that for you. And then we've got this here. So in this particular case, I'm just going to leave that at 0 for now. NOC threshold. Now we've got another table based on engine speed, and this is the level at which we say any NOC noise below these numbers, don't do anything about it. The control will do nothing. The moment the NOC signal goes above, let's say 5,000 RPM in this case, or 5,000, it will start to retard the timing proportional to the amount of signal noise is over the threshold limit. Okay, in the previous webinar we show you a picture of how that works, give you some examples. Then there's the recovery rate. Okay, I've just got a single number here. So what this is meaning, if you have a look up at the units here, this is degrees per second. So what this is saying is once we've got, for example, 10 degrees of retard out, this is the speed at which the ignition on that individual cylinder gets put back into the engine. So with a number of 5 here, we're saying 5 degrees per second. So if we had 10 degrees out from a NOC event, then that means it would take 2 seconds before the timing was back in on that particular cylinder. Again, we can configure that to it's got a 2-axis table on it, which is engine speed and engine load normalized, which is a channel that represents cylinder pressure in the engine. Well, we'll just leave that for now. NOC trim gain. And this is the active gain or multiplication factor of the amount that the NOC signal goes over the threshold. So again, in a simple example, if our threshold is 25 and a NOC event goes to 35, that would mean that we have 10% over the threshold limit. So with a gain factor of 100, that would be 100% of 10, which would mean 10 degrees was removed from that cylinder. Nice and simple. So this is out by a factor of 10 from the M800. If you've done a lot of M800 NOC control, then NOC control in the M800 would have, for the same equivalent number, it would be a number of 10 in the gain of the M800, and it's 100 here. It's different by 1 decimal point, if you like. Anyway, it's percentage of the percentage over the NOC signal over the threshold. We'll go over this again live when we get some data. NOC trim limit. So we could have a big NOC event, and it could calculate that 20 degrees needed to come out of the engine. In this particular case, with this LS1 engine, often it's only got 20 degrees in it, and if we were to pull 20 out of it, that would be an excessive amount. So you can have a look here, and you can specify maximum amounts of ignition retard for any given area. This is a nice simple table here saying, okay, above from 3000 up, we can pull a maximum of 15 degrees. Again, that's nice and simple. Depends on the engine and the fuel you're running as to the numbers that you'll put here. Alright, nice basic parameter here, the NOC window start. Most systems will run between 10 and 60, 10 degree start and a 60 degree window. So pretty much start with those parameters, and you wouldn't change it from there unless you're going to do proper window analysis using Goldway software. Alright, the window width pretty much always going to be 60, has been successful on everything we've done, and I'd suggest you start with that. The remaining 3 parameters here are just to do with the warning. You can get a warning mode to enable, and there's actually 2 ways of getting that warning to trigger. You can have it trigger when the NOC threshold level is exceeded by a certain amount, so that's the actual signal level. And you can actually get it to trigger when the NOC, the active trim gets too high. So for instance, we might have the ability to pull 15 degrees of timing out, and we might keep getting in a NOC event on the same cylinder, and the trim, the retard on that particular cylinder might keep ratcheting up and up and up, and it might start with 5 degrees and then go to 8 to 10 because it keeps knocking. And if it keeps knocking, then the amount of active trim will keep coming up, and then when it gets to this particular level that we could specify here, let's say 11 degrees, at 11 degrees we can have a NOC warning system be activated, and then can either show up on the screen, or you can trigger a light with it, or whatever you like. Alright, so that's the basic setup for a start, and probably the easiest thing is to go back into the tuning page and have a look there. So if we've allocated our quick key properly, if I press F7, we'll jump straight to that screen, and that's where we are. Alright, so what we're going to do is start this engine, and the way to calibrate a NOC system properly, as with any NOC system really, is to safely introduce detonation in the engine at a nice, as low a cylinder pressure as you can, in a controlled manner while you're listening to the engine. You need to know that an engine is knocking and how bad it's knocking in order for you to make a judge of whether the system's working correctly and to help you calibrate it. It's obviously a subject that you've got to be very careful with. You've got to be an experienced tuner and know what detonation sounds like, or NOC sounds like, and know if you're going too far. If this isn't something that you'd be comfortable with, that's not something we'd recommend that you dive in and do. Alright, so assuming you have that knowledge, and if you're an established tuner, you should have that, should be used to listening for detonation, or most people will anyway. Right, so we're going to make this engine go now, and we'll go live and have a look, and we'll go through some process of getting this to work. Alright, I'm not sure if you can hear it in the background. It's reasonably quiet, so you can see it coming across the screen now. So at this point we've got, I've configured this screen, the NOC levels and trim screen, to show 8 cylinders all at the different frequencies that we configured. So there's frequency A, B, C and D here, and we can see all the noise coming out of them each of those frequencies is represented here, or the results of the system measuring the frequency or the noise at that particular frequency. Thing worth noting here that I haven't mentioned to date is that the ECU actually uses the frequency that's installed or parametered in the level A, or frequency A. That's the one that the system uses for its control, and in this particular case I've put the threshold on that particular time graph, or that particular panel on the time distance graph. So best thing for us to do is now to safely as we can introduce some NOC and see the results. Now this really isn't the ultimate way of measuring or analyzing which frequency is best. You really should do that through log data, because the screen itself updates quite slowly by comparison. I think it's something like 25 or 30 hertz. NOC events can happen and be there and gone at frequencies above 50 hertz. So in order to do this properly, we should look at the logging. Now I've got it so that we can analyze it, at least for the purposes of training, using the screen, and that'll save you having to listen to me revel on for half an hour or more. So anyway, so we'll just pop across to the ignition screen, and we need to introduce something in the ignition tables that will cause the engine to detonate. It's got reasonable fuel in it, so we're going to need to put a fair amount of timing in it. So if I just press F5 and then F5 again, that takes me to the ignition table. So if we go give it focus here and go up, and at quite a low engine speed here, we can get some NOC to happen if we get enough ignition timing into it. And we'll start with 34 degrees. Alright, so assuming the engine and everything's up to temperature and things are happy, I'll turn the water and air on for the dyno. Alright, so we just make sure our lambdas are nice and safe. We're aiming for a nice rich 0.80 here. And we press F7, we can see things scrolling across here. Now normally you'd log this and listen. I'm going to switch my headphones on here and have a listen. And of course the engine's cooled down a fair bit since we tested this last. We're starting to see a little bit of NOC happening. Alright, so I can hear a little bit of NOC there. Alright, and we can see it turning up on the screen there. Okay, now we can just press T here, and that goes to telemetry mode. You'll see the connected is flashing. Just turn the engine off. Shut everything down. Alright, so now we've done that little bit of testing here, and we've got some data. I'll just cancel that for now, otherwise we'll lose that. Alright, so for you to do this properly, I'd suggest you download the logging and have a look at this in i2. Just for today, we can have a look at it here. There's enough here for us to see some reasonable results. So if I just double click on here, in fact if I press F6 here and go to full screen, this is almost exactly the same as looking at it in i2. Alright, so we can see up here we've got our ignition channel logged, and I was punching up and down from 17 to 34 to try and get it to have a little rattle. Alright, so we got something to happen here, and I'll just come out a little bit, it makes it a bit easier to see. Alright, so if we have a look, and what you've got to be careful of when you're looking at data like this is that what can appear to be a bad NOC on one particular frequency and not on another could be because of your scaling. So you've got to make sure that your scaling on all your 4 frequencies is all the same, and I've done that in this particular case. So normally I'd press F5 for the properties for this, but because we've stolen the F5 for the fuel and ignition, we go Alt F5 and we can see the properties. So just going through here, so you'll see I've manually set up 0 to 75 on all of those panels there. So if we have a look, and we've got one particular NOC event here, so let's get on top of that. Now we can, just like I2, we can just push the min-max average, so M, and that pops up all those there. There's probably a fair bit of information there, but we can see the maximum on this one, that particular, there it is there, 26.7 on that particular cylinder, 32 at this frequency. Alright, not much at that frequency and not much there, so I'll just get rid of that because we can see that frequency C is showing knock up the best. You can see here nothing much going on. When we do, there's a little ping here. Again, frequency C shows it, almost nothing at any of the others. Okay, so this cylinder here, cylinder 8, is having a little rattle there, and nothing really shown up at frequency A or D. So the winner on the day for the test is frequency C. So what are we going to do about that? So we'll just go press F6 to get this back to the normal mode. Alright, and actually press F. Actually, we're going to go down to the frequency setup, which is down in initial setup 2. Alright, so frequency C is 10,000 hertz, which is 10 kilohertz. So that's our winner. So we want to bring that to frequency A because this is the frequency that the control uses. Alright, and now that we know frequency C, which was 10K, was good, we want to now start bringing in these other three somewhere close to that and see which one is better. So 9,500, maybe 10,500, and 11,000 hertz. Alright, so we would then retest that and have a look, introduce the knock event again, and make sure that maybe 10 kilohertz right on the knocker is the best frequency to be at. It could end up being 10.5, it could end up being 10,350. By just zooming in test by test, you can get the exact frequency that will show knock the best. Alright, now in this particular case, one small step I did leave out was if you had a lot of cylinder variation, cylinder differential variation, if you like. Let me go back. Let's go back to tuning and knock. We can look at, we'll just zoom in here, the actual individual output of all the cylinders here. And this is really usually done at a higher engine speed. So under full load, you'll be able to balance the cylinders a little tighter. Now this is potentially not happening here, but the idea is to actually, when you do a full ramp run and you know it's not knocking, is to look at these knock percentages here, and using these individual gains you will change the percentage of gain on each individual knock channel, and that will bring all the channels themselves close together, all the values, the channel values close together. Now, because on this particular engine and the location of the NOC sensor and the quality of the NOC sensor, they're all pretty close, certainly for this test, then we didn't need to do that. To calibrate the system properly, you would go through a full ramp and look at those individual gains and balance them as good as you can. Alright, just unzoom that back again. Alright, so and you can see eventually, if we were to do a full ramp run and the background noise with no detonation was similar to this, you want to change your threshold level to be just above that, say 5 to 10% above that, and you definitely want to make sure that the threshold was going to be below or would be crossed by any knock event that happened. So the threshold in this particular case, if this is where we were looking, you would want around that kind of level there where I've got the mouse. Right, so that's further down the track. I think this webinar's got you far enough through to be able to start the setup and get you down the path of learning how to get it working. You can press F1 at any time in any of the screens, and that'll give you some more help, and we'll keep updating webinars as time permits and questions keep rolling in. Alright, so thanks for listening and good luck, and we'll catch you next time.